Welcome to the deep dive. Ever feel like your AWS cloud setup is just, well, chaos? Like you're lost without a map?
Uh-huh. It can definitely get complex quickly.
Today we're talking about getting that map. We're diving into using Terraform on AWS for infrastructure as code, basically taking control.
Exactly. It's about defining everything, your whole cloud environment, in code you can actually read and understand, not just clicking around hoping for the best.
And this isn't just theory. We're basing this on a real project presentation that walked through the whole thing.
That's right. Setting up a VPC, subnets, an internet gateway, even an EC2 instance, plus the security rules. And crucially, how to store Terraform's own brain, its configuration, securely.
So the mission today, let's break down the core steps and maybe more importantly, the why. Why use Terraform this way? We want to give you the essential takeaways.
Yeah, distill it down. Think of it as the shortcut to grasping how this whole IAC thing works securely on AWS.
Okay, let's dig in. One of the first things I noticed about the project was how everything was split up. Different files for different parts.
Ah, yes. Modularity. That's like fundamental. It makes everything so much easier to manage.
How so?
Well, instead of one giant scary file, you'll have maybe a backend.tf for storing the state, then a bucket.tf just for the S3 bucket that holds that state long term.
Right.
Then VPC.tf for all your networking stuff, the VPC, subnets, gateway, EC2.tf for the actual server.
Makes sense, like chapters in a book.
Exactly. And you'll usually see variables.tf to define options and terraform.tfrs to set the actual values. It keeps things clean.
And easy to fix if something breaks, I imagine.
Definitely. You know where to look.
Yeah.
Much better than wading through thousands of lines of code.
Okay, but the very beginning seemed a bit weird, starting with a local backend. Doesn't the state need to be stored somewhere safe, like S3, right away?
Yeah, that's the classic chicken and egg problem.
Yeah.
Terraform needs to store its state file somewhere from the get-go.
Right.
And long-term, you absolutely want that in S3 for safety, collaboration, all that good stuff.
Yeah.
But you need Terraform to create that S3 bucket first.
Ah, I see. So Terraform needs a place to remember things while it builds its permanent memory palace.
Precisely. So you start by telling it, okay, for now, just keep the state file on my local machine. It's temporary.
A bootstrap step.
Exactly. It's just to get that foundational S3 bucket created.
And the project mentioned Terraform init at this stage. What's that doing?
Terraform init is always your first command. It initializes the working directory. In this case, it sets up that local backend we just talked about.
Okay.
And importantly, it downloads the necessary provider plugins, like the AWS provider, so Terraform knows how to talk to AWS APIs.
Got it. Prepping the tools and the workspace. So local setup done, init run. Now we build the real storage that secure S3 bucket. The project used Terraform apply, dist target. Why target just the bucket?
Good question. The tier target flag tells Terraform, only focus on this specific resource right now. We only want to create the S3 bucket at this point.
Why the caution?
Well, the rest of the infrastructure doesn't even exist yet in our code, technically. But mainly, the S3 bucket for the state is critical infrastructure itself. We want to make sure that specific piece is created correctly and securely before we try building anything else that depends on it.
Get the foundation right first. Makes sense.
It minimizes the blast radius if something goes wrong early on. So Terraform apply, dash target os 3 bucket.terraform state, assuming that's the internal name we gave the bucket resource in our bucket.tf file.
Right. And the project stressed making this bucket super secure. Unique name, versioning, encryption, blocking public access. Let's break those down. Why is each one important?
They're all crucial because that state file is sensitive. It describes your infrastructure. First, a unique name. That's basic. But it prevents clashes and makes it harder to guess.
Okay.
Versioning. This is your safety net. Every change to the state file creates a new version. If you mess up, you can roll back. Think of it like infinite undo for your infrastructure state.
That sounds incredibly useful.
It really is.
Yeah.
Then server-side encryption. This protects the state file data while it's just sitting in S3. AWS handles the keys. You just enable it, like a built-in lock on the vault. And finally, blocking all public access. This is non-negotiable. You never want that state file exposed. This setting ensures only authorized IAM users or roles can even see the bucket exists or access its contents.
Okay, these really lock it down. So the secure bucket exists. Now we need to move the state file from our temporary local setup into this permanent S3 home. How's that done?
Right, the migration. First, you update your backend.tf file. You change the configuration from local to S3.
Okay.
And you specify the bucket name you just created and the AWS region it's in. You're basically telling Terraform, okay, stop using the local file, start using this S3 bucket instead.
Changing the address, like you said.
Exactly. Then you run Terraform init again.
Again? Why?
Because the backend configuration has changed. Terraform init reads that change, sees you're switching from local to S3, and it asks you, do you want to copy your existing state from local to this new S3 backend?
Ah, a confirmation step.
Yes, a very important one. You double check it's the right bucket, the right region before you say yes, and it moves the state file over the network to S3.
And why is that confirmation so critical? Just to avoid mistakes.
Pretty much. You want to be absolutely sure you're pointing Terraform at the correct, secure S3 bucket you just set up. Migrating state is a big deal. Getting the destination wrong could cause all sorts of problems down the line. It's a measure twice, cut once moment.
Got it. So state is now safely in S3. What are the big wins here beyond just security?
Oh, huge advantages, especially for teams. Now the state is remote and shared. Anyone on the team with the right permissions can run Terraform, and they'll all be working from the same up-to-date state.
Okay, that avoids conflicts.
Exactly. And S3 backends support state locking. If I run Terraform apply, it locks the state file so you can't run it at the exact same time and potentially corrupt things. Only one person modifies the infrastructure at once.
Like checking out a library book.
Sort of, yeah. Plus, you get the versioning we already talked about, a full history of changes. And the encryption protects the data at rest. It's just much more robust and collaborative.
Right, makes total sense for anything beyond a solo project. Okay, foundation laid, state secured, time for the main event. Building the actual AWS environment. Let's start with the VPC. What goes into that?
The VPC is your private network slice in AWS.
Right.
So first, you define the VPC itself, give it an IP address range, usually enable DNS support too, so things inside can find each other by name. Then you create subnets within that VPC. The project used a public subnet in a specific availability zone for resilience.
Okay, a neighborhood within the VPC.
Yep. To connect that public subnet to the outside world, you need an internet gateway, IGW, attached to the VPC.
The highway exit.
Right. And then you need to tell traffic how to get to that exit. That's the route table. You create a route that says traffic going to the internet on a point of 0.00 should go via the internet gateway.
Got it, like road signs?
Exactly. And finally, you associate that route table with your public subnet. So anything launched in that subnet knows how to reach the internet.
Okay, VPC, subnet, gateway, route table, association. That builds the network. Now, the EC2 instance, the virtual server, what are the key parts there?
First, the security group. Think of it as a firewall attached to the instance.
Right, controlling traffic.
Yep, you define rules, like allow incoming SSH traffic so you can connect remotely. Allow HTTP and HTTPS if it's a web server.
Makes sense.
Then you define the EC2 instance itself. You specify things like the instance type, the operating system image, AMI, and crucially, you tell it to launch into the public subnet we just created.
So it lives inside our defined network.
Correct. Then you associate the security group with that instance, applying those firewall rules. And finally, you usually configure it to get a public IP address so it's reachable from the internet.
Okay, network built, server defined, firewall attached, public IP assigned. And the command to make all this happen is Terraform apply.
That's the one. When you run Terraform apply now with the state in S3,
Right.
Terraform looks at your code, compares it to the state file in S3, which is currently empty except for the S3 bucket itself, and figures out what needs to be created.
It generates a plan.
Exactly. It's an execution plan. It shows you, I'm going to create this VPC, this subnet, this IGW, this EC2 instance. It lists everything out.
And it asks for confirmation again.
Yes. Critically important safety step. You review the plan, make sure it looks right, type yes, and then Terraform goes off and makes all the API calls to AWS to build everything.
Phew. Okay, code becomes reality. Now, how do we double check? How do we verify everything actually got built correctly?
Best way is the AWS Management Console. You log in and literally go look.
What are we looking for?
Check the S3 service first. Make sure your state bucket is there and the terraform.tf state file is inside it.
Okay.
Then go to the VPC service. Find your VPC, check its IP range, look at its subnets, find your public subnet in the right AZ, check the internet gateway is attached, look at the route tables, find the one associated with your subnet, and check the route to the IGW.
Right. Follow the trail.
Exactly. Then jump over to the EC2 service, find your running instance, verify it's in the public subnet, has the right security group attached, and has a public IP address.
So a visual inspection in the console confirms what the code defined.
Precisely. It also helps you connect the code concepts to the actual AWS resources.
Okay, built, verified. Now, the cleanup. The project mentioned Terraform Destroy. Is taking it all down really that simple?
Surprisingly, yes. Terraform Destroy reads your state file, figures out everything it's currently managing, and generates a destruction plan.
Shows you what it's going to delete.
Yep, lists all the resources, the EC2 instance, the VPC, everything. And again, it prompts for confirmation. You have to type yes to proceed.
Another safety net.
Absolutely. You don't want to accidentally nuke your production environment. Once you confirm, it sends the delete commands to AWS for all those resources.
What about the S3 state bucket itself, especially with versioning turned on? Does Destroy handle that?
Generally, yes. When versioning is enabled, Terraform Destroy is usually smart enough to delete all the object functions first and then delete the bucket itself.
Usually.
Well, it's always good practice to double-check in the S3 console afterwards just to be sure it's gone, especially if you might have put other files in there manually. But typically, Terraform handles the cleanup of versioned objects within the state bucket it manages.
Okay, that's reassuring. So create, verify, destroy. That's the ideal flow. But things go wrong sometimes. Let's talk troubleshooting. IAM permissions.
Ah, yes, a common one. Terraform acts using AWS credentials, right? An IAM user or role. If that user or role doesn't have permission to, say, create a VPC, EC2, create VPC, or an S3 bucket, S3 create bucket, AWS will block the action and Terraform will give you an error.
So the fix is?
Go into the AWS IAM console and add the missing permissions to the policy attached to the Terraform user or role. The error message usually gives you a pretty good clue about which permission is needed.
Okay, give Terraform the right keys. What about deleting the S3 bucket? Sometimes that fails. No.
Yeah, AWS won't let you delete an S3 bucket if it's not empty. If Terraform somehow missed deleting an object inside maybe the state file versions or something else, the bucket deletion will fail.
So you have to.
You have to manually empty it first. Go into the S3 console, delete all the objects and versions inside the bucket, and then run Terraform Destroy again. Then it should succeed.
Right. The presentation also mentioned using Halak false during backend migration sometimes. When would you do that? Sounds risky.
It is risky. Terraform uses locking to prevent simultaneous state modifications. But sometimes, maybe if a previous run crashed, a lock can get stuck. If you're getting lock errors during Terraform init for the migration and you are 100% sure no other Terraform process is running against that state, you might use Terraform init.lock false to bypass the lock check. But it's a last resort. You risk corrupting your state if you're wrong.
Use with extreme caution. Got it. And the worst case, a corrupted state file. What then?
That's bad, yeah. Terraform needs that file to know what's what. The presentation mentioned Terraform innate reconfigure. That can sometimes fix minor issues by forcing Terraform to reread its backend config.
But if the file in S3 is really messed up...
This is where versioning on the S3 bucket saves you. You can go into the S3 console, find a previous known good version of your terraform.ts state file, download it, and then use the Terraform state push command to upload that good version, overwriting the corrupted one. It's another reason why versioning is absolutely essential for your state bucket.
Wow. Okay, so versioning isn't just for rollbacks, it's for disaster recovery too. These troubleshooting tips are super practical. So let's zoom out. What were the key wins demonstrated by this project structure and approach?
I think it clearly showed how to set up that secure S3 backend that's foundational. It showed defining and deploying a complete AWS infrastructure from code. It highlighted using modular code for clarity and maintenance. It embedded security best practices from the start for the state and the resources. And it showed managing the whole infrastructure lifecycle, create, update, destroy.
And thinking even bigger picture, what are the main advantages of adopting this whole infrastructure as code approach with Terraform? Why should teams bother?
Oh, the benefits are huge. You get version control for infrastructure, like Git for your servers and networks, track changes, roll back easily.
Consistency?
Absolutely.
Yeah.
Consistent and repeatable deployments, spin up dev, test, prod environments that are truly identical. It massively boosts collaboration. The code is a single source of truth everyone works from. The code itself becomes living documentation. No more guessing how things are configured. And ultimately, it simplifies management. You declare what you want. Terraform figures out how to make it happen. It moves infrastructure from manual tinkering to a proper engineering discipline.
From assembling furniture by hand to using automated blueprints. I like that. This has been super insightful, really clarifying how Terraform brings control and structure to AWS.
It really does. And it makes you think, doesn't it?
How so?
Well, how might adopting infrastructure as code change more than just how a team builds things. How might it fundamentally reshape the way they collaborate, how they understand their systems, and how they approach solving problems in their tech environment? It's more than just automation. It's potentially a shift in culture, too.